Hello, this is Chlorine from Exam Help Lab. Today I'll be solving Chemistry Paper 2 AS Level Structured Questions 9701 Paper 2, variant 3, October, November 2019. Starting with question number 1, part A, chlorine can be prepared using the following reaction. Manganese oxide plus hydrogen chloride gives manganese chloride plus water plus chlorine gas. Part 1, explain why manganese oxide solid is described as an oxidizing agent in this reaction. Refer to oxidation numbers in your answer. So, oxidizing agents are which oxidize other reactants and they get reduced in the reaction. And by reduction, I mean that their oxidation numbers decrease. Chlorine gas is getting oxidized from -1 to 0. Over here, manganese oxide is the oxidizing agent which has brought oxidation to chlorine gas. Part 2, state what you would observe during this reaction. So chlorine gas is being given off effervescence. Part B, the halogens chlorine, bromine, and iodine are all volatile elements. State and explain the trend in volatility down group 17. So again, volatility is a property which describes how fast a substance state will be changing to vapor form. So volatility decreases down group 17. And the reason why is it so is since number of electrons increase as we go down group 17, thus van der Waals forces, which are induced dipoles in this case, they increase. Hence, it gets harder to break bonds as we go down group 17. So volatility decreases. Part C, chlorine undergoes disproportionation during many chemical reactions. Part 1, write an equation for the reaction of chlorine with cold aqueous sodium hydroxide. Explain why it is a disproportionation reaction. So equation is chlorine reacting with NaOH. Since chlorine gas is reacting with cold NaOH, it will have different products as compared to if it was reacting with hot aqueous sodium hydroxide. It will give NaCl plus NaClO plus H2O. If the chlorine gas was reacting with hot aqueous sodium hydroxide, it will have given some other products. Explanation to it is why it is called a disproportionation reaction, because chlorine is both oxidized and reduced. Thus, it is known as a disproportionation reaction. In the same reaction, chlorine is undergoing both the changes. Part 2, one of the products of the reaction of chlorine with hot aqueous sodium hydroxide differs from those in CIE. Identify the compound that is formed in this reaction that is different from that formed in the reaction in C part 1. So that would be NaClO3. Part D, state and explain the use of chlorine in water purification. So the chlorine compound which is being used in water purification is HClO to kill microorganisms. Part E, under certain conditions, chlorine undergoes a free radical substitution reaction with ethane. Part 1, state the conditions required to initiate this reaction. So reaction conditions for free radical substitution reactions are UV light. Part 2, write the overall equation for this free radical substitution reaction. So ethane is reacting with chlorine which gives you, it's a substitution reaction. It's a free radical substitution reaction, so it will be C2H5Cl plus HCl. Question number 2, part A. Complete the table to give details of the type of bonding and structure shown by some of the oxides of pair 3 elements. Okay, so this is all you have to learn. What kind of bonding is present in sodium oxide? This is ionic bonding. Magnesium oxide, this is again ionic. Aluminium oxide, this is ionic too. Silicon oxide, this is covalent. Sulfur trioxide, this is also covalent. Coming down to structure, sodium oxides has got ionic bonding. This is a giant lattice. It has got a giant lattice structure. So does MgO, giant lattice. Aluminium oxide has also got giant lattice structure. Silicon oxide has got giant molecular structure. Sulfur trioxide has got a simple molecular structure. Part B1. Explain why the boiling point of silicon dioxide is much higher than the boiling point of sulfur trioxide. This is due to silicon dioxide having stronger bonds As a result, it requires higher energy to break those bonds. Also, sulfur trioxide has weak van der Waals forces. Part 2. Aluminium oxide is an amphoteric oxide. Explain what is meant by the term amphoteric. Use chemical equations to illustrate your answer. So, an amphoteric oxide is a substance which reacts with both acid and an alkali. Now, aluminium acting as a base, reacting with HCl will give out water plus aluminium chloride, while aluminium oxide reacting with a base as an acid suppose NaOH, this gives water plus NaAl bracket OH bracket 4. Now I need to balance this equation. Part 3. What you would observe when a small sample of sodium oxide is placed in water. So let's write the equation first. Sodium oxide reacting with water. This gives us sodium hydroxide. Okay, a solid will disappear. Solid sodium oxide will disappear because it has formed a highly alkaline solution. Part C. Selenium is a group 16 element which shows similar chemical reactions to sulfur. Selenium reacts with fluorine to form SeF6 molecules. Predict the shape of a molecule of SeF6. Part C. Selenium is a group 16 element which shows similar chemical reactions to sulfur. Selenium reacts with fluorine to form SeF6 molecules. Predict the shape of a molecule of SeF6. So just like SF6, it has octahedral shape. The most stable oxide of selenium is SeO2, selenium dioxide. Gaseous selenium dioxide reacts to form a solid polymer as shown in the reaction. One selenium oxide double bond is replaced by two selenium oxygen single bond to form a polymer. The bond enthalpy of selenium oxygen double bond is 514 kilojoules per mole. Use these data to calculate the bond enthalpy in kilojoules per mole of SeO single bond. Okay. So the question says that one SeO double bond is getting replaced by two SeO single bond to form a polymer, and the energy change has already been given to you, which is minus 346 kilojoules per mole. So I'll be writing positive 514. It is positive because bond breaking is positive, and I'll put in negative 2x since bond formation is negative and there are two SeO single bonds forming. So 2x, x is the value of the bond enthalpy of SeO single bond, and two SeO single bonds are forming, which is unknown to us, and the total enthalpy change is minus 346. So x has got a value of 430 kilojoules per mole. Part 3, SeO2 shows similar chemical reactions to SO2. Suggest an equation to show the reaction of SeO2 with aqueous sodium hydroxide. So if SO2 were reacting with NaOH, it would have given you Na2SO3 plus water, would give the same kind of product with selenium dioxide reacting with NaOH. This will give you water plus Na2SeO3, like it would have given Na2SO3 with SO2. Question number 3. Crude oil is a natural source of hydrocarbons that are used as fuels. Part A. Hydrocarbons with low relative molecular mass are used as fuels in industry, in the home, and for transport. There is a high demand for the hydrocarbons with low molecular mass. Part 1. Name the process by which long-chain hydrocarbons are broken down into shorter-chain hydrocarbons, and that process is called cracking, through which smaller hydrocarbons are taken from larger hydrocarbon chains. Part 2. Give one reason why hydrocarbons with low MR are suitable for use as fuels. So the shorter the chain, the easier it is to break them down, or the easier it is to burn them. So to burn it easily, we need hydrocarbons with low MR or shorter chains of carbon atoms. Part 3. Incomplete combustion of hydrocarbons can release carbon monoxide into the atmosphere. Write an equation for the formation of carbon monoxide from the incomplete combustion of butane. So C4H8 plus O2 gives carbon monoxide plus water Part 4. Identify an analytical technique that can be used to monitor the levels of carbon monoxide into the atmosphere. Outline how this analytical technique may be used to monitor the levels of carbon monoxide. So to monitor the levels of them in the environment, we can use infrared spectroscopy. And what property of it will be differentiating the levels of carbon monoxide that is which is present in the atmosphere? That is by comparing their wavelengths. Just like the property that is boiling point, which is being used in the fractional distillation to separate different substances from one crude oil, over here same way we will be comparing wavelengths to separate or to compare the levels, or to monitor the levels of carbon monoxide in the atmosphere. The property which is being used over here is wavelength. The property which was being used in the fractional distillation was boiling points. Part B. Thiophene is an organic compound that is found as a contaminant in crude oil. Part 1. Construct the equation for the complete combustion of thiophene. Include state symbols in your answer. So, thiophene is found as a liquid. It reacts with oxygen, which is a gas, and this gives carbon dioxide, which is again a gas, plus water, which is liquid, plus an additional product which comes from sulfur over here, so it's sulfur dioxide, which is also a gas. Now I need to balance the equation. Part 2. A student carries out an experiment to determine the enthalpy change of combustion of thiophene. Explain the meaning of the term enthalpy change of combustion. So you need to learn the definitions of all the enthalpies, whether it is neutralization, it is combustion, or whatever enthalpies they are. You just need to memorize the definitions, because these kind of questions will usually lead to scoring 2 marks, and they're just very easy. You just need to learn the definition. So that's an enthalpy change when 1 mole of a substance completely combusts. Part 3. The student uses the following apparatus in the experiment. Mass of water in copper container is 200 grams. Initial temperature is 18.5 degrees Celsius. Highest temperature of water is 37.5 degrees Celsius. Calculate the heat energy released in joules by the reaction. Assume that 4.18 joules of heat energy changes the temperature of 1 centimeter cube of water by 1 degree Celsius. Assume no heat is lost to the surroundings. Okay, so the equation is energy is equals to mass multiplied by specific heat capacity of water into the temperature change. Over here, mass has been given to us, which is 200 grams. We need not convert grams into kilograms, so we will just write 200. The specific heat capacity is 4.18. This is the specific heat capacity of water, and that will be multiplied with temperature change, which is 37.5 minus 18.5. 37.5 minus 18.5, and we need not convert this Celsius into Kelvin too. So heat energy released will be equal to 1584 joules. Part 4. The student used 0.63 grams of thiophene in the experiment. Calculate the enthalpy change of combustion of thiophene. Include a sign in your answer. Okay, so So the first step is to calculate number of moles of thiophene over here being used up in the experiment. So moles of thiophene is equal to mass is given to us, which is 0.63, divided by relative formula mass of thiophene, which is 48 plus 4 plus 32.065. Hence, moles of thiophene are 7.49 into 10 to the power minus 3. Okay, so this means that enthalpy change for 7.49 into 10 to the power of minus 3 moles was 1584 joules. So for 1 mole, how much would it be? Since they're asking you to find the enthalpy change of combustion, which is when one whole mole of substance, which is thiophene over here, completely combusts. Over here, this much energy was provided to combust this much of thiophene. So how much energy will be required to combust 1 whole mole of thiophene, which is what we have to calculate. So we need to divide 1584 by 7.49 into 10 to the power minus 3 moles. But before you do that, you have to convert joules to kilojoules, since in the question they are asking you to find enthalpy change of combustion in kilojoules. So you need to convert this energy over here to kilojoules first. So energy released is equals to 1584 divided by 1000. And then you divide this whole by 7.49 into 10 to the power -3. And thus you will get 2120.4 kilojoules per mole of energy. Also asking you to include a sign in your answers. Enthalpy change of combustion is always negative due to the fact that energy is given out. This will be given a sign of negative. CH3 tri-CCHO is used in the synthesis of some antibiotics. Part A1, give the name of CH3 tri-CCHO. So first of all, I'll draw the structure to make it easier for you to give name to it. So CC. This carbon, first carbon atom, is attached to 3 methyl groups. This carbon atom over here has an aldehyde functional group. So I will start labeling my longest chain from the side, which gives the least number to the carbon atom of my functional group, which is CHO aldehyde group in this question. So I'll start labeling it this way: 1, 2, and 3. This is the longest straight carbon chain for me. I would have taken, I could have taken this one, I could have taken this one, but since this is a straight chain, so this is much easier for me. There are 2 methyl groups attached to second carbon atom, and longest chain has got 3 carbon atoms. Thus, naming ends with propanol, and the word nol comes from CHO group. So I'll write 2,2-dimethyl propanol. Since I've got 2,2-dimethyl means on second carbon atoms I've got 2 methyl groups attached to it, and propanol, prop word comes from my straight chain has got 3 carbon atoms, so prop. Anol comes from the functional group CHO. Part 2, state the hybridization of the carbon atom labeled with an asterisk. Okay, so this is sp2 because it has got 3, because this carbon atom has got 3 sigma bonds, which is this one, and 1 from the double bond, and has got 1 pi bond, which is again 1. This double bond means there is 1 pi bond and 1 single bond, so this carbon atom has got 3 sigma bonds and 1 pi bond. Part B2, reaction sequences are shown. Part 1, reaction 1 is an oxidation reaction. Identify the reagents and conditions for reaction 1. Okay, so this is an aldehyde, this is a carboxylic acid, this is undergoing oxidation reaction. So the reagents for it, the aldehyde is turning into a carboxylic acid. For this, we need a reagent, dilute sulfuric acid, plus our chromate ion, which is K2Cr2O7. Along with that, we should have some kind of temperature around it set, so heat under reflux. Part 2, A, CH3 tri-CCOOH is a solid at room temperature. B, CH3COO CH2 tri-CH3 is an isomer of A. B is a liquid at room temperature. Explain the difference in the physical states of A and B with reference to any intermolecular forces that may exist. First of all, I'll draw the structures of both A and B. A looks like this. Carbon atom has 3 methyl groups attached to it. Then there is a carboxylic acid functional group. This is A. B is an ester. Has got a methyl group and then an ester linkage. This is joined to 2 carbon atoms with each 2 hydrogen atoms. And finally, 1 more methyl group. Okay. They're saying in terms of their intermolecular forces, you need to mention you need to explain the difference in their physical states. So I see that A has got a hydrogen bonding over here between O and H, while B has just only got van der Waals forces between molecules. So I'll write A has hydrogen bonding while B has simple van der Waals forces. And you all must know that hydrogen bonding is the strongest among all the bondings, or at least stronger than van der Waals. That is why it exists as a solid at room temperature. Part 3, give the balanced equation for the reaction of CH3 thrice CCHO with NaBH4 to form S. Okay, NaBH4 is a reducing reagent, so it brings reduction to the aldehyde over here. So reduction of an aldehyde gives a primary alcohol. I should write it too as to balance the equation. Draw the structure of the organic molecule T that reacts with A in reaction 2 to form U. Suggest a catalyst for reaction 2. Okay, so A is a carboxylic acid. It has got a carbon bonded to 3 methyl groups. And then the carboxylic acid's functional group. Then it reacts with some kind of reagent and produces U, which is an ester. And U has a structural formula of this is CH3. This is the ester linkage. This part of ester is coming from carboxylic acid A, while this part of ester is coming from an alcohol, which then forms an ester. When an alcohol and carboxylic acid, they react with each other, they form ester. So this part is coming from a carboxylic acid. That's why this one must be coming from an alcohol. So T will have a structure of T has a structure which somewhat looks like this. This is propane 2-ol because the hydroxyl functional group is on the second carbon atom, and the catalyst which is being used in this reaction is dilute H2SO4. Part C, X, Y, and Z are all isomers of CH3 thrice CCHO. A summary of some of the reactions and properties of X, Y, and Z is shown in the table. X and Y each contains a carbonyl group. Complete the table with the expected observations for the reactions of X and Y with 2,4-D and pH. So 2,4-D and pH, which is dinitrophenylhydrazine, is a reagent which identifies if a carbonyl compound is present in a solution. Failing solution turns red from blue if an aldehyde is present in a solution. Over here they say that X and Y each contains a carbonyl group, which means that a positive result will be shown when X and Y both are added to 2,4-D and pH. So orange precipitate will be seen when both X and Y are added to 2,4-D and pH. Part 2, identify the functional group present in Y that causes the recorded observation with Fehling solution. So when Y is added to Fehling solution, the solution turns to red precipitate from blue, which means that it is an aldehyde group is present. Part 3, Y has a chiral center and exists as a pair of optical isomers. State what is meant by the chiral center. This is the center carbon atom, which is bonded to 4 different atoms or group of atoms, but they need to be different. They all need to be different. Part 4, draw the optical isomers of Y using the conventional 3-dimensional representation. It is bonded to a methyl group. It's bonded to H, then aldehyde group, then C2H5. And on to the right of the mirror, or the pair of this optical isomer, CH3 again, H, and the ethyl group. Part 5, ZC5H10O has a branched carbon chain. It shows geometrical isomerism. Complete the table with the bond responsible for each of the principal absorptions seen in the infrared spectrum of Z. So when you open up your chemistry booklets, you will see that the bond responsible for 3200 to 3600 per centimeter of a peak on infrared spectrum is the hydroxyl bond, which is OH. R indicates that any methyl, ethyl, or any alkyl group is present on the left of oxygen atom. Bond responsible 1630 per centimeter peak is the double bond between carbon atom. Bond responsible for 1050 per centimeter peak on infrared spectrum is carbon single bonded to O. Part 4, draw the skeletal formula of Z. So they say over here that Z has a branched carbon chain, and it also shows geometrical isomerism, and it has a molecular formula of C5H10O. And previously in the question, they also mentioned that Z, when it reacts with 2,4-DNPH, doesn't show any change. When it reacts with Fehling solution, it doesn't show any change either. And on the infrared spectrum of Z, it shows these 3 peaks, means a hydroxyl with an alkyl group is present, a double bond C to C is also present, C to O single bond is also present, and it also shows geometrical isomerism. It has a branched carbon chain with 5 carbon atoms in total, means there are 2 over here. We are left with 3 carbon atoms now, and there is carbon to oxygen to hydrogen atom present. So I'll put one carbon over here with 2 hydrogens and 1 hydroxyl functional group. And it also shows that, and it also says that it shows geometrical isomerism, means I cannot put 2 methyl groups on the left of carbon because that's not valid. They need to be on both different carbon atoms, but they need to be across each other. So 1 methyl group over here and 1 methyl group over here. This forms a geometrical isomer. And now I'm left with 1 hydrogen atom because 1, 2, 3, 4, 5 carbon atoms are here. 3, 6, 7, 8, 9. So I'll put the 10th hydrogen over here, and we are given with only 1 oxygen. So this is the structure of Z. Part 7, X contains a carbonyl group. X reacts with HCN in the presence of a small amount of NaCN to form C2H5 twice COOH, as shown. Draw the mechanism of the reaction of X with HCN. Draw the structure of X and the intermediate. Include all charges, partial charges, lone pairs, and curly arrows. C is bonded to C2H5. And there's one more bond or two more bonds which need to be here on carbon atoms to complete the valency of carbon, but we need to decide which one is that. When that reactant reacts with HCN, it produces a hydroxyl group as well as a cyanide group, which means a ketone must be there, because when a ketone reacts with HCN, this bond will break and H will be attached to it, and then a cyanide ion will be attached to this carbon to form CnNOH. So this must be a ketone. Okay, so the first step is to breaking the bond of HCN. This bond will be breaking heterolytically, where cyanide ion will take away both the electrons and H will be left with a positive charge, partial positive charge. Okay. The next step, or the second step, is breaking the C2O double bond, where again oxygen takes both the electrons. So oxygen will be given a partial negative charge and carbon will be given a partial positive charge. And I'll have to show this with the help of an arrow that both the electrons have been taken away by the oxygen, and over here both the electrons were taken by cyanide ion, and now oxygen has got a lone pair of electrons. The next thing which is to be shown is that now this carbon atom over here has a partial positive charge, which will be attracted by cyanide ion over here because it has got a lone pair of electrons. So this cyanide ion will now get attracted towards this positive, partial positive carbon atom. So the intermediate is C, now that it will only have a single bond with oxygen having lone pair and negative charge. C2H5 over here, C2H5 over here, and cyanide ion has now been attached to the carbon atom. And this negative charge will be attracted towards the H plus, because all its electrons were taken away by cyanide ion and now H doesn't have any electrons. So it will be attracted towards this oxygen atom. So oxygen's lone pair will be attracted towards H plus, and this H will now get attached to the O to form OH group. Part 8, state the role of NaCN in the reaction in C. Part 7. So NaCN acts as a catalyst and it remains chemically unchanged throughout the reaction. So I'm done solving this paper. Thank you for watching.